Next, we will discuss the pyramid of energy. A pyramid of energy shows the amount of energy available at each trophic level over a specific period of time. It is measured as energy per unit area per unit time, for example, kilojoules per square meter per year. Like the other ecological pyramids, producers form the base, followed by primary consumers, secondary consumers, and tertiary consumers. However, instead of showing the number or mass of organisms, it represents the amount of energy transferred through each trophic level. A pyramid of energy always has an upright or true pyramid shape because energy decreases at every trophic level. It is considered the most accurate way of representing energy flow within an ecosystem, as it clearly demonstrates how much energy is available to organisms at each stage of the food chain. As energy moves from one trophic level to the next, a large proportion is lost. Much of the energy is used during respiration and released as heat, while some is lost in waste materials through digestion and excretion. Consequently, only a small proportion of the energy, approximately 10%, is converted into new biomass and passed on to the next trophic level. A pyramid of energy is important because it provides the clearest picture of energy transfer within ecosystems. It explains why energy becomes progressively less available at higher trophic levels and why food chains are usually short, with only a few trophic levels. It also highlights the inefficiency of energy transfer between organisms. As shown in the diagram, the flow of energy begins with approximately 1 million joules of sunlight reaching the producers. Through photosynthesis, producers capture only about 10,000 joules of this energy and convert it into chemical energy stored in food. Primary consumers receive about 1,000 joules by feeding on the producers, secondary consumers receive around 100 joules, and tertiary consumers receive only about 10 joules. This demonstrates the 10% rule, where only about 1/10 of the energy at one trophic level is transferred to the next, while the remaining energy is lost to the environment through respiration, movement, heat production, and waste. As a result, the amount of available energy decreases steadily from the producers to the top consumers, giving the pyramid of energy its characteristic upright shape. So, this brings us to the end of Unit 19.1, Energy Flow. We have covered all the required syllabus specifications in detail and explored the key concepts needed for a strong understanding of this unit. Don't forget that the topical notes are available in both the description and the pinned comment for your revision and further study. Stay tuned for the next unit, where we will continue our journey through Chapter 19 and cover the remaining syllabus content step by step. Thank you for watching, and I'll see you in the next lesson.